Okay, in section 4.8, we're doing the same thing we did in 4.7, except we're going to take it a step further, and we're going to look at some special cases. First off, we're going to look at the case where we have, and this is something we've been solving all semester really, where we have a point O and our forces are all concurrent, meaning that they all pass through the same big point. So I have a force coming in from this direction. I have a force maybe coming over here. And I have a force here. Say. So I have three forces heading towards O. So concurrent forces, we can then replace all three of those forces with one resultant. Okay, for our second case, we have a situation where we have coplanar forces, but they're not necessarily concurrent. So we have a force in this direction. Maybe it's going through that point. We have a force in this direction. Maybe it also is going through that point. Maybe not, but I guess I'm drawing it like it is. And then I have another force acting somewhere else. I can still replace all those forces by a resultant. But with this force here, since it's not concurrent, I'm going to have to figure out the moment that it is causing here about O. So I need to replace that with also a moment. So we have a force and a moment. So these are like equal situations. But I can take this a step further. I mean, this is what we just did in the last chapter. I can take this step further. I think there's people watching this because I'm getting lag. Take this a step further, and I can take this moment and I can use this force to represent it by offsetting the position of this force, of my resultant force. Pretty clever, huh? Fr. And so now I offset it by some distance d. Oops, I wrote the distance d to the script O when I should be writing it to the point O. There. Okay, for the next case, I have parallel forces. I can replace these by a single resultant force. And a moment. And then I can do the same thing I did above. And replace this by our resultant's force offset at some distance. Same magnitude. Now I have a distance to count for that moment. So last case is the most general, have a resultant moment and a resultant force. This is equivalent to, I'll keep the resultant force the same here, and then what I'll do is come up with two components to my moment. So I'll have a moment that's perpendicular to this and a moment that is parallel. I need more room. Okay, instant more room. So here is our force, and then our parallel moment will be here. Well, I can offset this force some distance. Now, just as a comment here, this moment is a couple moment, so we can move it to where the force is, and I can resolve this into a parallel and perpendicular component. Components that are parallel and perpendicular to this force at some point, let's say O. And then I can move this force, but I'm stuck with this moment here. So I got rid of the perpendicular moment by moving the force a certain distance, but I'm stuck with this moment because it was along the same line of action. But since it is free moment, I can move it to our new point here, P. So we end up with a force and a moment acting at P. So again, in summary, we got a couple moment that is somewhere in the system, well, everywhere in the system, and we can figure out a resultant force of all the forces on O, and we can move our moment, but it isn't necessarily perpendicular to the force, but we can resolve it into perpendicular components to this force. Then we can move our force resultant a certain distance to account for this moment and eliminate it. And then we have to move this moment on top. We're left with just a component parallel to the force. Okay, let's solve this example. So let's figure out what our forces are first. Force 1. So I'm going to replace these two wrenches and the system of forces by an equivalent resultant force and a couple moment at point O over here. So I'm going to call my first force F1 300 newtons. That's this guy. My second force, let's call this, we're going to get it off of this guy down here. So we have 200 cosine of 45 I. This is actually going to be in the K direction. I minus 200 sine 45 in the K direction. And we have a final force here, which is just 100 in the J direction. These are all newtons. Put a newton here and newton here. Okay. Now I need the resultant so I can replace these and put them at O, the resultant at O. Resultant anywhere, but the resultant that we're going to essentially move to O is then I just sum all this stuff up. So I end up with 141.42 I plus 100J plus 159K so I could probably call this 141 I plus 100J plus 159K, and that's newtons. So that's the first part of the answer. Now, let's sum our moments about O. And let's write down some intermediate calculations I did. So you'll see where I got some of these numbers. So here's an intermediate calc. 200 cosine 45, I got 141.42. And for 200 sine of 45, I also got 141.42. Obviously, they're 45 degrees. So I'm going to calculate these with scalars. I think it's going to be easier. So I have x components, y components, and z components, and I just need to figure out distances to O. So first up is 300, this guy, who is 0.5. I'm going to call that a positive. Some of these are going to be tricky to figure out. So this first one's a K and a J with J crossing K, and using my right hand rule, that's going to end up giving me an I in this direction. So that's positive. So then I have a 142.42 with a distance of 11 or 1.1 meter. So this turns out to be a J cross an I, and J cross I gives us a minus K. So I now have got the Z component here with the same distance, 1.1. And then this is J cross the minus K, which gives us a minus I. Okay, that's all the forces turned into moments. So now we have these guys, free ones. We've got a 100 here. So that is in the K direction, positive. So plus 100K. Then I have this 180 down here, but it's at a 45 degree angle. And I have to break it up into two components. And there we go. So these are from the forces, and these are from the moments. We add all these together, and this is my result. Now, if I go back and I make one calculation on this whole thing up above, I end up actually with 121.71715. So I could really round this to this value down here and match the answer in the book.